Welcome students. Today we are going to discuss about the right circular cone. In this presentation, we are going to discuss the formation of a cone, curved surface area and total surface area of the cone. Right circular cone. Let us see these objects. It resembles the shape of the cone. See the definition given in our book. A right circular cone is a solid generated by the revolution of a right-angled triangle about one of the sides containing the right angle as axis. Simply we can say a cone is a solid that has a circular base and a single vertex. Let us see the formation of a cone. See here, it is a right-angled triangle. The base of the triangle is the radius of the cone and this is the height. And what is this new term slant height? We know the side opposite to 90 degree is called the hypotenuse of the triangle. That hypotenuse portion is called the slant height. We can generate a right cone by revolving a right triangle about one of its legs. If a right triangle is rotated about its perpendicular as the axis of rotation, the solid constructed here is the cone. If the vertex is over the center, then it is called right circular cone. In the first section of this chapter, we saw how a rectangle can be transformed into a cylinder. Now, like this, a right angle triangle can be transformed into a cone. Surface area of a right circular cone. See here. If a perpendicular cut is made from a point on the circumference of the base to the vertex, see what happened. The cone is opened up and the slant height of the cone is the radius of the sector and the circumference of the cone is the arc length of the sector. You please try to understand the conversion made here. Slant height of the cone is the radius of the sector. Circumference of the cone is the arc length of the sector. Before we get its lateral surface area, we need to know what is the sector of a circle, which we studied in earlier classes. A plane surface that is enclosed between two radii and the circular arc of a circle is called sector of a circle. See the diagram. The area enclosed by two radii and their intercepted arc is called the sector of the circle. If theta is the central angle, then area of the sector equal to theta by 360 into pi r square. Length of the arc is given. What is the area of the sector? Area of the sector equal to LR by 2 square units. L is the length of the arc, R the radius of the sector. To avoid a confusion, we have to know this transformation. See how a sector of circle is transformed to form a cone. Then what are the conversions made here? What is the radius of the sector? That is the slant height of the cone. Then area of the sector, curved surface area of the cone. Arc length, that is the circumference of the base. Please listen carefully the transformation made here. Radius of the sector is the slant height of the cone. Area of the sector is the curved surface area of the cone. Arc length is nothing but the circumference of the base. What is slant height? See the cone. Here ABC is the right angled triangle. Now this one is the base. Then AB height, BC R. Usually we represent the slant height by the letter L. AC hypotenuse, BC base, AB height, or radius H height, L slant height. We know Pythagoras theorem. What is Pythagoras theorem? The square on the hypotenuse is equal to the sum of the squares of other two sides. See, AC square equal to BC square plus AB square. Substitute the corresponding letters, we get L square equal to R square plus H square. we have to find slant height. So slant height equal to square root of r square plus h square. By rearranging the terms, we can solve for other lengths. See, the radius r can be found using this formula, r equal to square root of L square minus h square. Same way, the height can be found using the formula h is equal to square root of L square minus r square. Curved surface area of the cone. Curved surface area of the cone is nothing but area of the sector. We know area of the sector LR by 2. Now the slant height is the radius of the sector and circumference of the cone is the arc length of the sector. So instead of arc length we substitute 2 pi r and r we substitute L by 2. 2 and 2 get cancelled, so pi r L. Curved surface area equal to pi r L square units. Surface area of the cone equal to pi r L square units or radius L slant height. Total surface area of the cone. Total surface area equal to C.S.A of the cone plus base area of the cone. C.S.A pi r L. Then what is the base? Base is in the circular shape, so the area of the circle is pi r square. By writing pi r as a common factor, we get pi r L plus r as the formula. So total surface area equal to pi r L plus r square units. Hope you understand the concept. Once you visualize the formulas like this, you don't need to memorize it.